Good morning, class. How are you? I hope you are doing well. Yeah, we want to continue with our lessons. The other day we looked at two-dimensional shapes. And I hope you've done more reading on two-dimensional shapes. Yeah. So we saw that the two-dimensional shapes are also called plane shapes. They are called two-dimensional because we take the length and then the breadth. The other day we mentioned some of the examples. Now, we said that we have polygon. Example of polygons, I hope you remember: triangle, that is three-sided; quadrilateral, four-sided; pentagon, and so on. We also saw that a circle is also a plane shape. So today's lesson, we are going to look at lines of symmetry of plane shapes. We are looking at lines of symmetry. Good. Now, when we talk of line of symmetry, it's simply an imaginary line or axis that passes through a center of a shape or an object and divides it into two identical halves. Please, here the emphasis is that the line must pass through the center. It's an imaginary line, but it should pass through the center of the object. And at the end of the day, you should see that what is on one half is exactly the same on the other hand. So that is what is meant by a line of symmetry. Now, when we talk of symmetry, it's not only plane figures that we can associate lines of symmetry with. Any object at all. If we can ask ourselves, human beings as we are we symmetric? If you are symmetric, it means that there is an imaginary line that can be drawn so that at the end of the day, what is on one half will be the same thing on the other half. But today we are going to look at lines of symmetry of plane shapes. Plane shapes. I've already mentioned some of the plane shapes. Yeah. Now, what is a plane shape? Plane shape can have one or more line of symmetry. Every plane shape can have one or more lines of symmetry. In fact, some of them don't even have line of symmetry at all. So, lines of symmetry, it can be 0, it can be 1, 2, 3, and etc., depending on the shape of the plane figure. Now, how do we determine if a shape has a line of symmetry? How do we know? I've already said that it is an imaginary line which is drawn to pass the center of the object so that we have identical halves on both sides. So, how do we do this one practically? I hope I have a paper here, but you can follow because I've already given you this thing. Now, when you fold a shape, so if you have a paper, let's say it's a rectangular shape of paper. So, if you have such a paper, how do we do it? So, when you fold the shape and the folded parts fit exactly or perfectly on top of each other, that means the edges will match. Then that line is what we call line of symmetry. So when you fold a paper, I will do the demonstration. I'm just looking for a paper to do this demonstration. Just give me a minute. Good. So I have this. Assuming this is a rectangular shape. It's a rectangular shape. I want to determine whether this one has a line of symmetry. So what I'm going to do is that I'm going to fold this one and see, make sure the edges matches. So if I fold it this way, now what you see here is the imaginary line, which we call line of symmetry. So at the end of the day, if I unfold it, what I see here, is it the same thing over here? If yes, it means that this shape, which is a rectangle, has a line of symmetry. As I said, some have more than one. So for instance, I can decide to also fold it this way. Now fold it this way and open it. You could see that what I have on one side is the same thing on the other hand. So with this demonstration, you can see that a rectangle can have it has two lines of symmetry. Good. Let's move on. Now we also have an activity that I want you to do after this lesson. Let's get a cardboard. Then try to cut it into various shapes. Rectangle, triangle, and whatever. At the end of the day, try to go through what I was just doing. Fold it to see if you can have a line of, it has a line of symmetry, or if it is symmetric or not. I hope you do that one after the lesson. So let's move on. Now, we have plane shapes, as you saw on your slides, that the plane shape is there. There is a folded line. Now, you could see that I have my plane shape here. How do I know this one have a line of symmetry? All what I have to do is that I have to fold it along this line, dotted line. I fold it together. So after folding it, as you saw on your PowerPoint, you could see that the two halves are the same. What you see on one here is the same thing as two here. So they have the same shape. So what it means is that this line that we have drawn is a line of symmetry that is making this shape symmetric. Good. We also have other shapes. Now, the same figure, let's try to fold it in a different way and see. For example, we have it like this. Now, if we fold it along the diagonal like this, look at what is going to happen. Are we going to have exactly the same thing, on the two halves of the line of symmetry? I think no. Why? Because when you fold this one like this, look at from here to here, the distance here will not be the same thing here. This distance will not be the same. As you can see, this is longer than this. So it means that the line I've drawn here is not line of symmetry. Good. Now let's continue. We also have triangle. A triangle can have one or no line of symmetry depending on the type. You know, we have types of triangle. Do you remember them? I have forgotten some more. Okay, I remember we have equilateral triangle. What is an equilateral triangle? All the three sides are equal, and the interior angles too are equal. So for such a triangle, it's likely we are going to have three lines of symmetry. If I draw a equilateral triangle here, this side, and this side, this shows that it is an equilateral triangle. Now, I'm going to see how many lines of symmetry this one is having. Let's name the points. 1, 2, and then 3. So we have A, B, C here. Now I can decide to draw a line, an imaginary line from C to see if I can have the same, the identical halves. So I'll draw it this way. So as you can see, we have 1 and 2. You can see that the area of 1 is the same thing, not about the area. It's identical to what we have here is the same half we are having here. It means that this line, this is one of the lines of symmetry. We can also decide to project a perpendicular from point A, as we have here. This one too is going to give me two identical halves. I can do the same thing here. And I can also have two identical halves here. So what it means is that when a triangle is a equilateral triangle, it has three lines of symmetry. One from C perpendicular, then one from A, and then B. I hope you are getting it. So we said that a triangle can have one or three. So it means that there is no triangle that has two lines of symmetry. Is that true? I hope you can verify. Now let's look at other triangles too. Apart from a equilateral triangle, we also have another triangle. That one, two sides are equal. This means that this side is equal to this side. This side is not the same. So we have, let's name them again, A, B, and C. So with this, you could see that the line here and this are not the same. Let me draw it well so that you see what I want to project. Go. A, B, C. This is what we call isosceles triangle. With this, the properties of this triangle is that two sides are equal. Two sides are equal. And then two interior angles too are equal. That is the property or properties of isosceles triangle. Now, let's see if you can have how many lines of symmetry are possible here. In the first place, this figure is symmetric. Because, let me try to project a line from here. The imaginary line or the axis. Now, with this line, you can see that the line have divided the figure into two equal halves, identical. What we have here is the same thing as what we have here. So, this is a line of symmetry. So, one. Now, let's investigate whether we can have others. So, let me clean this. I'm using my hand. If I come to observe you and you use your hand, it's unprofessional. So you have to use duster. If you want to erase something, use your duster very well to erase it. Good. So this time I'm going to project a line from point A. I don't know how to even project it. No matter what you do, the side on this, let's say X, side X and side Y will never be identical. It will never, no matter how you draw it. So it means that there is no way we can have line of symmetry here. When we project it from here to, it's going to give us the same thing. So this shows that this particular type of triangle just have one line of symmetry. Just one. Good. I hope you are getting the concept. Now let's move on to just investigate other triangle. We also have the other triangle. Which triangle is this? Okay, I can hear you saying it's an. Let me hear you. Okay. We also have one we call scale triangle. I remember when in my first station when I completed school and I was sent to a village which I will not mention. Then I was teaching this one. Then I said, this is scalene triangles. One of the students said, he mentioned Skene's triangle. Please, it's not Sikeni, it's what? Scalene. Why do we call it scale? It means that it has, there is no scale in drawing it. None of its sides are equal, unlike the equilateral and then the isosceles. So the scalene triangle is said that none of the sides are equal like this. You can see that this side is different from this side and is different from this side. This is what we call scalene triangle. None of the three sides are equal. So with this type of triangle, I don't know, there is no way you can demonstrate it with any type of triangle. There is no way you can get a line of symmetry from this triangle. No way. So such a triangle, that is scalene triangle, has zero line of symmetry. It means that it has no line of symmetry. In other words, we will say that it is not symmetric. It is not what? Symmetric. Good. Let's continue. We also, apart from triangle, we have others, that is quadrilateral. Now, I want you to try the third type of triangle. That one, I will not demonstrate it here. Try and let me know whether it is symmetric or not. And that triangle is right angle triangle. Right angle triangle. I know why I'm saying that. With right angle triangle, one of the interior angle is 90 degrees. So we are going to, I hope you look at that one. One of the interior angle is 90 degrees. We can have two types of them. Let me just demonstrate. One, if I have this, and this is a right angle triangle, because one of it interior angle is 90 degrees. We can also have something like this. This one too is a right angle triangle. But when you look at this side is equal to this side. It is a right angle triangle by virtue that one of its interior angle is 90 degrees. Somebody is saying that, say, this one too can be isosceles triangle. That is why I said go and look at that one. We will talk about that one later on. Now let's move on to quadrilaterals. Quad means four, as you know already. Four-sided. Now with four-sided figures, just like the triangle, we have types. Some have the same size throughout. Now when we were talking about polygon, we said that we have some polygons called regular polygon. Regular polygon. What makes a polygon regular? What makes a polygon regular? A regular polygon is a polygon with equal size. So we know polygons start from triangle upwards. So if I have a triangle and that triangle have equal size, all the three sides are equal, just like what we saw in a equilateral triangle. That is is a regular polygon. Now a regular polygon for quadrilateral is what? Thank you. It's square. With square, all the four sizes are equal. All the four sizes are equal. So when you take a square, for instance, I have my square here, not drawn to scale, but in geometry, if I do this, it means all the sizes are equal in geometry. It doesn't matter whether it's drawn to scale or what. So this is a square. Now, how many lines of symmetry can we get? Let's take note of this. I don't know how true is it. I will do my investigation. I want you to also do it. After this lesson, I want you to get me one quadrilateral that has 3 lines of symmetry. Just one. Because maybe I was born before computer, so I don't know so many. So what I know is that a quadrilateral can have 0 line of symmetry, 1, 2, or 4. That is what I know, but I don't know, maybe with the new technology there is other. So I want you to do that investigation for me. Get me a quadrilateral that has 3 lines of symmetry. Now let's take this square. As we saw in the triangle, this square here, I can draw my imaginary line here. This half would definitely be identical no matter how it is. Once I draw it from the diagonal to the other diagonal. I can also have this one here, making 2. I can also have it like this, making 3, and then I can have it like this. So in this case, it means that a square has how many lines of symmetry? It has 4 lines of symmetry. 4 lines. That is 1, 2, 3, and then 4. So a square is a symmetric figure with 4 lines of symmetry. Now let's move on to a rectangle. as I was demonstrating on the board, a rectangle is also a four-sided figure. But the difference between rectangle and triangle is that with rectangle and square is that the square have all the four sides equal, but the rectangle has two opposite sides equal. This side here is equals to this side is equals to this side. Now, by virtue of the nature of the figure, if we fold this one diagonally like this, we are not going to have the same figure on both sides. So the line here, the diagonal here, unlike what we saw in the square, the diagonal here cannot be a line of symmetry. This one too cannot be. So when you look at this figure, the only possible lines of symmetry is either this. Now when you fold it this way, you will see that what you see here is exactly what you see here. I can also fold it this way, as I was demonstrating. I hope I have done this illustration on the PowerPoint. This is just to supplement it with a video. So as you see in your PowerPoint, that is how it is. So we have two lines of symmetry for rectangle. We also have kite and others. Please go through the same procedure and determine the number of symmetries that we have. We also have some irregular quadrilateral. I call them irregular quadrilateral because they are not what you call regular polygons. They are irregular. What makes them irregular is that they are just like the scalene triangle. None of its sides are the same. So automatically, I don't know, but there is no way we can get a line of symmetry from an irregular quadrilateral. If I draw a line, a figure like this, this one is a typical example of irregular quadrilateral. These are the points. So with this, there is no way you can get a line of symmetry. I don't know, maybe you can get it, but I don't know how to get a line of symmetry for this figure. So we say that this figure is not symmetric. It is not symmetric. Good. Now let's consider some polygons. I want you to do that, though it is in your PowerPoint. You take the polygon, the regular ones, then the number of sides. I want you to investigate the number of sides of a polygon and then the number of lines of symmetry. I want you to get the relationship between the two. The number of sides of a regular polygon and the number of lines of symmetry of the polygon. I hope you think about that one. Good. Now we are left with one interesting figure, and that one is the circle. A circle is also a plane figure. Good. Now with the circle, let me draw a circle on the board and let's see. I have a circle like this. It has a center. We are saying that the line of symmetry should pass through the center. So if I start from any point, next time I'll bring my blackboard instrument so that you see how to do it. Our next lesson is construction. So that one we are going to do justice to that. Good. So this is a line, my circle. Now, how many lines of symmetry do you think this circle will have? How many lines of symmetry do you think this circle will have? You have started counting. Try it and let's see. But from a practical point of view, I can have this one. This is one. This one too can be one. Is that all? Is that all the possible lines of symmetry? Because if I draw this line here, which later on you know it is called a diameter. The half here is the same thing as half here. Now if I draw it this way too, it's the same thing. What we have here is the same thing we have over there. So how many lines of symmetry do you think a circle can have? In fact, the circle can have uncountable number of lines of symmetry. because I can decide to draw a diagonal from here. I can decide to draw it from here. I can draw it from here. I can draw it. I can continue drawing till thy kingdom come. So what it means is that a circle has infinite number of lines of symmetry. Do you know, if we remember infinite set, a set that has no end. So the number of symmetry of a circle is infinite. You can't get it. You can continue to draw it till the kingdom come. You won't get it. Good. So I want you to do this. I've already sent you that exercise through the Google class and then the V class. And the assignment I want you to do is that just consider all the English alphabet, the upper cases. That is, we don't, you know, in this modern world, please don't go and say capital A, capital B, capital C. If you say that, somebody will laugh at you. He will say you are too archaic. Right now, we have uppercase and then lowercase. So when I say uppercase, that is what formerly was referred to as capital letter. So you take all the upper cases of the English alphabet from A to Z. Then you identify which of these letters are, symmetric. How many of them are symmetric? If they are symmetric, how many number of line of symmetry do they have? So that is your assignment. In addition, just look around your house, your room and whatever, and just mention any two other things that are symmetric. I hope you have questions. You can bring the questions. I will deal with the questions as when they come. So I would like to end the lesson here. But please continue doing the exercise I gave you. Just get a cardboard, cut it into various shapes. You can cut it to rectangle, triangle, all the type. And try to fold it and see if you can get the line of symmetry. I want you to get prepared for the next lesson. But please, on the next lesson, what we need is a straight edge, a ruler. We also need a compass, pair of compass. We are going to look at geometric constructions, how to bisect angle, how to bisect a line,